Following is an excerpt taken from the second of 3 sessions that make up the 7-hour-long Module 5 training course on process piping design. This brief excerpt touches on one of the sample problems described in the course. This problem steps the viewer through the process of determining and selecting a wall thickness, then calculates the maximum allowable working pressure for the selected wall schedule. Sample problem 3. In this case, we will be calculating for the pipe wall thickness. The key data points we will use in doing this are a design temperature of 650 degrees F, a design pressure of 1,380 psig, the nominal pipe size is 14 inch, the material is ASTM A335 grade P11 seamless with a corrosion allowance of 0.05. Calculating pipe wall thickness based on B31.3 is a two-step process. The first step calculates for what is referred to as the pressure design thickness, lowercase t. The second step is to integrate the results of T with that of the mechanical allowances such as threads or grooves, corrosion or erosion. In doing so, we end up with what is referred to as the minimum required thickness, lowercase t sub m. In calculating for T, there are two options. For this example, we will use the first equation. For coefficient y, in which T is less than capital D over 6, the capital D representing the pipe OD, the reader is referred to table 304.1.1, but the heavier wall pipe, in which T is equal to or less than capital D over 6, the reader is referred to the equation at the bottom of the slide. The number of table 304.1.1 tells you where to find the equation in close proximity to paragraph 304. In solving the equation, we will start at the second step in which we have replaced the symbols for their values. In the third step, we have solved for the pressure design wall thickness, which is a result of 0.577 inches. The T sub m calculation would then look like this, with the result of 0.627 inches minimum required thickness. So the pipe schedule thickness will need to meet or exceed this value. Selecting an appropriate pipe wall thickness that meets or exceeds the T sub m value of 0.627 inches, we can quickly scan the available wall thicknesses for our 14-inch NPS. The pipe wall that exceeds that value, as we can see, is the Schedule 80 at 0.750 inches. We can now calculate for the MAWP, the maximum allowable working pressure of the pipe. And one thing needs to be mentioned here. The term MAWP for maximum allowable working pressure is not a term that is used in B31.3. It is a term that comes from the boiler and pressure vessel code. We are borrowing the term to be used for pipe like it is used for pressure vessels. It allows us to know the pressure limits of the pipe itself. To continue, in order to arrive at the maximum allowable working pressure for the pipe, we need to first of all determine the pipe's burst pressure. We will determine the pipe's theoretical burst pressure by using the modified Barlow equation as shown at the top right. The 0.875 in this equation takes into account the manufacturer's pipe wall tolerance. Because the pipe is seamless, both W and E sub j in this case are a factor of 1. It negates the need to adjust the results of the burst pressure calculation by applying the calculation identified as adjusting for weld joint. So we can skip that step. But for actual documentation purposes, whether or not the weld joint strength reduction factor, W, or the longitudinal weld joint quality factor, E sub j, are a factor of 1.0 or something else, you will still need to include this calculation to simply indicate that this step was considered. The first step in solving for pipe burst pressure is to replace the symbols in the modified Barlow equation above with values for the 14-inch NPS pipe we are using. In step 2, we simplify the calculation, and in step 3, we have the resulting 525 psig burst pressure. For step 4, in accordance with the Boiler Pressure Vessel Code paragraph UG 101 subparagraph M, we can then divide the burst pressure results by a safety factor of 4 to arrive at the maximum allowable working pressure of 1400 psig for the pipe, which exceeds the 1380 psig design pressure set for this surface. This marks the end of this excerpt. For more information on the complete course, please contact us at courses@wmhuittco.com. In the subject line, enter Request Info on the Module 5 Piping Design course. Thanks for watching.